So in my previous two videos, we did parts A and B on this free response question. Today we're going to do part C, which is calculating the volume of a solid that has a known base and a known cross-section. So part C says this region R is the base of a solid. And if you take cross-sections of this solid, so it's coming out at you, so if you slice it, each cross-section perpendicular to the y-axis is a square. So if you slice this perpendicular to the x-axis, like let's go this slice right here, that's going to be a square. So that's going to be the base of the square, and the height of the square is going to come right at your face right here. So as always, we're going to set this up like we're going to take one representative slice. This slice is going to be a square. So how am I going to draw that? It's going to look like this. This is delta x. That's really this length. This little length is delta x right here. So a square is length times height. So when you do these, we're just adding up all the volumes, and the volume is length times height times width, and the width is always this delta x, which is going to be dx when we add up all these volumes. So we are really just interested in the length, this, times the height, which is coming out at you. If it's a square, the length and the height are the same thing. So the area, which is really the formula for these types of problem, A is the cross-sectional area. So we need to figure out, first of all, well, what is the length of this part? Maybe you think of it as this part. Well, it's the same way we measure everything. We have our arrow drawn, and we need to figure out the length, which would be the top value of y, which is 6, minus the bottom of the arrow, which is on the y, which is defined by this graph. So that's 4 times ln of 3 minus x. So this length, the length of this green double-sided arrow, I guess, is 6 minus 4 times the ln of 3 minus x. I have some unnecessary parentheses there, but that's only the length. We need the area, so it's that length times the height. Since it's a square, you got that. So that's all you need. Notice there's no pi out in front of it because we're not revolving. This is just simply integrating that cross-sectional area. Now, I did forget my limits temporarily. Those are easy. That never changes. When you do these problems, you're adding up all of these rectangles in the area, or squares, I should say. So we're going from this point, which is 0, to this point, which is 2. I forgot my square here. That should be it. That should do it. Let's throw that in the calculator. I can use what I already had put in there. We have 6 minus this whole thing squared. I'll get rid of this minus 4, and we should be good to go. Delete. All right, so that looks right. We'll graph it. We'll integrate now from 0 to 2. Second calc integral from 0 to 2. And our answer is 26.666. 6, or 26.667 if you're a rounder. That is all. So as soon as I can figure out how to stop this thing, here we go. Thanks for watching.